All right, ICP, this is Mr. Simmons and your Section 15.1 Composition of Matter notes. This should be used in conjunction with your 15.1 notes here that you got in class. Here we go. All right, so 15.1 Composition of Matter. Vocabulary for this section is substance, element, compound, heterogeneous mixture, homogeneous mixture, solution, and colloid. Matter can either be a substance or a mixture. So all matter, all of the stuff in the universe is divided into two categories, a substance or a mixture. A substance is matter with a fixed composition. That means it doesn't change under normal circumstances. So it can either be a compound or an element. So a compound or an element is going to be the elements on the periodic table, which we'll learn about. A compound is a mixture of elements. And so two examples are water and aluminum. So water is H2O, no matter where you find it, whether it be a million years ago on Australia or North America, water is always going to be H2O, two hydrogens and one oxygen. Aluminum is a substance because it's always Al. It's always the same type of atom. And so no matter where you find it, aluminum is always the same. There are some differences with neutrons, but in general, aluminum always has a certain number of protons and electrons. It changes a little bit, but aluminum is aluminum no matter where you find it. Same with water. So that's what a substance is matter with a fixed composition. That means it doesn't change under normal circumstances. And there are two different types, element or compound. So elements are the atoms in the substance where they all have the same identity. Protons, electrons, neutrons. They cannot be made simpler by any chemical process. So these are going to be things you find on the periodic table. Gold would be an example. Here's two examples. Copper. Pennies are now copper coated. There's zinc in the middle. And then graphite. Graphite is pure carbon. That is an element. And this is also an element. The wood is a mixture of different elements, substances. Compounds are pure substances that are made of more than one type of element. So if you have O2, which is oxygen, in its gaseous form in the atmosphere, that's still an element because we only have one type of element there. But if we have two or more, then it's a compound. So it's combined in fixed proportions. So what does that mean? Well, it means that the atoms are always the same, no matter where you find them. So familiar compounds in their formulas, we have vinegar. It's also called acetic acid scientifically, and it's always CH2COOH. If we change this formula is no longer vinegar. If we change H2O and we pass electricity through it and form oxygen and hydrogen, it's no longer water. And that's what a substance is. No matter where you find it, it's always the same thing. If you have one type of atom, then it's an element. If you have two or more different types of elements, then it's a compound. Another compound is grain alcohol, ethanol, C2H5OH. If we change this formula at all, it's no longer the same thing. That's what a substance is. Cane sugar, sucrose, C12H22O11. We almost have that 1 to 2 to 1 ratio, so we know this is from our biology days that this is a carbohydrate, and it's a couple sugars put together. So if we change this formula at all, it's no longer sucrose. That's what a substance is. All right, mixture. So all matter, let's go back. All matter is either a substance or a mixture. So we describe substances. They are things that have fixed compositions, which mean they don't change. And if they do change, it's no longer the same thing. A mixture, on the other hand, is something that you can still call the same name. So one example would be Kool-Aid. If you make it really sweet or don't really put that much sugar in it, it's still Kool-Aid. If we take a pizza and we change the toppings around, it's still pizza. Whereas a substance, if you change things around, the atoms around, elements around, it's no longer the same thing. So let's go back down to mixtures. All right. So mixtures are matter that consists of two or more substances. So we have substances that are physically mixed together but not chemically combined. So they exist in the same space at the same time, but they're not sharing electrons or trading electrons or anything like that. We'll learn about chemical compounds, chemical bonding later, but they're just physically mixed together and they can easily be separated. So mixtures can be separated by physical means. Some examples are granite. So your granite countertops are mixtures. Sand has silicon dioxide and a couple other things in there. Soil, concrete, salad dressing. And we can take mixtures and we can easily separate them. If I have a mixture of sand, salt, and iron, I can use a couple of physical properties to separate them. I can get the iron out through magnetism. I can put water in the sand and the salt will dissolve, and I can drain it out. So I just have the sand, and then I can boil off the water and get the salt. So it's not easy, but it's a lot easier than chemically dividing compounds. So mixtures can be separated by physical means. Granite, sand, soil, concrete, salad dressing are all examples. Now there's two main types of mixtures. There's heterogeneous mixture and there are homogeneous mixture. So let's look at the root word. Hetero means different, so we see different phases. So a mixture that does not appear to be the same throughout is a heterogeneous mixture. We can see the different parts. That if I take a piece of pizza and you take a piece of pizza, we may get different proportion of toppings. Maybe I get more mushrooms and pepperoni and you get less. But we still call it the same thing. And so a heterogeneous picture, you can visually see the differences between the different parts. You have more than one phase of matter. You have different parts to it. It's easy to see. So concrete, you can see all the speckles in it. You can see different parts of it. Oil and water can be a mixture, but they don't really mix. But they can be in the same place at the same time. And pizza is my favorite example. And pizza, the works pizza, you can have all these different parts, and every slice is a little bit different, but we still call it pizza. Homogeneous mixtures are mixtures that appear to be the same throughout. So if we mix our Kool-Aid really well, we'll have a homogeneous mixture where you can only see one phase. You can't see different parts. And if I pour you a glass and I pour me a glass, we're basically getting the same thing. So examples would be salt water. The salt is evenly distributed throughout. It could be stainless steel. It could be 14 karat gold. So 24 karat gold is pure gold, nothing else. But pure gold is pretty soft, so they mix in some copper and some other things to make it stronger. And so you go down in carats. 14 karat gold is usually what you wear because you don't want it to bend and get scratched and stuff like that. But that is a homogeneous mixture of different elements, mainly gold, but some copper and some other things too. But you can't see the different phases on my ring. You can't see the different parts, the different elements, the different pieces. And so that's what a homogeneous mixture. Homo mean the same, so as it looks the same throughout. So for example, except for the ice cubes, this is a homogeneous mixture of cola, I guess, some Coke, and you can't see different parts to it. But if we look microscopically, we can see, or even electron microscopically, we can see the different parts. So we can see some sodium, I'm guessing, carbon dioxide, some sugar, and they're all mixed pretty evenly into one uniform mixture. So we can't see different parts here. So this is a homogeneous mixture. If we take the ice out, the ice makes it a heterogeneous mixture. So types of homogeneous mixtures, and I need to fix that slide. Solutions are one type. A homogeneous mixture of particles so small they cannot be seen. So this is your Kool-Aid, your salt water. When you dissolve stuff in water and mix it up, and it changes the flavor or the look or whatever, that's a solution. So solutions are the best mix of all mixtures, that it's pretty evenly throughout. It's not easily separated by physical means. So examples are antifreeze. It doesn't always have to be liquid. It could be air. Air is mostly nitrogen, but has all these other elements and compounds mixed in with it. Powdered lemonade or Kool-Aid or whatever, that'd be another example of a solution. So we have small particles that dissolve into something bigger. So later on we'll talk about solutes and solvents. So the solvent is what does the dissolving, the most of the matter. Solutes are what get dissolved. So if we have lemonade here, the powder would be the solute, and the water in the lemonade would be the solvent. It does the dissolving. And air, nitrogen is the solvent, and it dissolves all the other gases that are floating around. Oxygen and carbon dioxide and nitrogen and stuff like that. Colloids are homogeneous mixtures in which particles are larger than those of a solution, but not heavy enough to settle out. But not heavy enough to settle, I think is the end of this. Somehow got cut off. So milk's an example. Paint, glue, stuff like that, kind of gloopy things. Could be fog. We have an example of a colloid. We have water particles suspended in air. So let's review. Question 1. A blank is a type of matter with a fixed composition. Is it colloid, mixture, substance, or solution? What do you think? It is a substance. So substances are elements and compounds. Basically, if you change the arrangement of atoms, it's no longer the same thing. I can take pizza and change it in different ways and still get pizza. I can take Kool-Aid and add more sugar and still have Kool-Aid. But a substance you cannot change. If you do, it's no longer the same thing. Question 2, or here's the answer. The answer is C. A substance can either be an element or compound. Question 2, I swear I fixed this. How are compounds different from mixtures? The atoms in compounds are combined in fixed proportions and cannot be separated by physical means. A mixture is made of 2 or more substances physically blended together that can be easily separated by physical means. So that's the main differences. So basically what we're doing is we're taking mass, we're doing chemistry, taking mass, all the matter that's out there, and trying to organize it so we can understand it better. So we're going to start out with, here, I'm going to show you this sheet here. Let's find it. So let's take a look at our concept map, which I need to fix a little bit. So we can take all matter, all the mass that's out there. We can divide it into 2 different groups. It can be a substance or it can be a mixture, is the missing bubble here. A substance, when made up of like atoms, are elements. So if all the atoms are the same, it's an element. If it's 2 or more different atoms, it's a compound. If we have mixtures, we can, if it's evenly blended and you only have one phase, this can be a homogeneous mixture. If you can easily see the different parts, it's a heterogeneous mixture. Homogeneous mixtures can be divided into 2 different things. It can be a solution where particles are too small to be seen, and then we also have colloids when particles are small but not heavy, or are small but not heavy enough to settle. All right. So that is classification of matter. So we're taking matter, we're categorizing it, classifying it, and to try to understand it better. Thank you, and have a great day.